the preparation of alcohol by hydration of alkenes. In our previous class, we have studied the two methods of hydration. The first one was acid catalyzed hydration of alkenes, and the second one was oxymercuration, demercuration. Today we will learn the third method of hydration of alkenes, that is hydroboration followed by oxidation. And this method of hydration of alkene is an indirect method of addition of water. So an unsymmetrical alkene is treated with a mixture of diboron in a medium tetrahydrofuran, leading to the formation of trialkyl boranes. And these trialkyl boranes, when oxidized with alkaline hydrogen peroxide, will give us alcohol. Now this unsymmetrical alkene to alcohol, this is addition of H2O according to anti-Markovnikov's rule. Now we will see step by step how this is anti-Markovnikov's addition of water. Now in hydroboration, this diboron, that is B2H6, acts as BH3. Now this BH3 is a Lewis acid. See, boron is short of octet here. 1, 2, 3, 4, 5, 6. So it will be electron acceptor, and we know that electron acceptor means Lewis acid. Now if BH3 is a Lewis acid, then this boron is the electrophilic center. That means it will be delta plus. Now this BH3, we can visualize it as BH2 plus and H minus. So now what we will do, we will add this BH3 to an unsymmetrical alkene. So let us add this. Let us take this unsymmetrical alkene. We will add here BH3. And now this BH3, what I have told you that we will visualize is as BH2 plus and H minus. Now in BH3, this H will be transferred as H minus. And we know that the negative part of the addendum will go to that carbon which contains less number of hydrogen. So in this addition, it will follow Markovnikov's rule. Here it is not anti-Markovnikov's. The net result will be anti-Markovnikov's. So this carbon will add this H minus. So H, and what will happen here? What is left behind? BH2 plus, so BHH. This compound is known as alkyl boron. See here, boron, 1H of BH3 is replaced by alkyl group RCH2CH2 group. So this is alkyl boron. This is the first step. So now let us see what will happen in the second step. In the second step, this product of the first step, that is this alkyl boron, will add to another molecule of this unsymmetrical alkene. So you all write with me this unsymmetrical alkene. Now this will add this compound. So I am writing it as RCH2, CH2, BH, H. Now you have to visualize this as RCH2B plus and this part will be minus. That means once again what will happen? This H will be transferred or added to this alkene as H minus and it will go to which carbon? It will go to this carbon according to Markovnikov's rule. So the product will be, see, I will add this hydrogen as H minus. So R, C, H, this H is added, single bond, C, H, H. Now this carbon will get connected to this boron. So B, and this is connected to H and CH2, CH2R group. Achha, now this is known as dialkyl boron. See, this is BH3. So here 2H are replaced by 2 alkyl group. So this is dialkyl boron. Write this one. Now what will happen? In the third step, this compound that is formed in the second step will add to another molecule of that unsymmetrical alkene. So write this unsymmetrical alkene. After that, I will write this compound RCH2CH2, this B, this H, then again what I will write? CH2CH2R. Now let us see how the dialkyl boron will add to another molecule of this alkene. Now here again what will happen? This H will be transferred as H minus to which carbon? To this carbon, Markovnikov's addition. H. Now what is left? This two you have added. So this part is left now. So this carbon will get connected to this boron and this boron is connected to this alkyl groups. So now this is trialkyl boron. See, all the 3H of this BH3 is now replaced by 3 alkyl groups. So this is trialkyl boron. Write this trialkyl boron. So how many molecules of alkene is required here? 3 molecules. So now let us see what will happen. This trialkyl boron that is formed in the last step is now treated with an alkaline solution of H2O2. And this is oxidation. Now, in this case, we will require 3H2O2. Now, let us see how we will add this 3H2O2. What I have written this? Once it is H2O2, we can think it in this way, na? H2O2, so I have written OH, OH. Now here also I am writing OH, OH. And here also OH, OH. You are writing this way. So I have written here 3H2O2. This is one H2O2. This is another H2O2. This is the third H2O2. Now after this, the bond will break in this way. See what is left here? R, CH2, CH2, OH. So R, CH2, CH2, OH. Here also you see R, CH2, CH2, OH. Here also R, CH2, CH2, OH. So we will get 3R, CH2, CH2, OH plus. Now see this part. Plus what is left behind? B, OH, OH, OH. See this B, OH, OH, OH. This we can write it as H3BO3. So this hydroboration followed by oxidation ultimately leads to the anti-Markovnikov's addition of water. See this. RCH2, CH2OH. Our starting alkene was so water is added here according to anti-Markovnikov's rule. See OH to this carbon and H to this carbon. So the net result of hydroboration followed by oxidation is anti-Markovnikov's addition of water. Suppose if our starting compound is propene. So if you were asked that propene is treated with here H2O2 in alkaline medium, what is the product? So what we will do? In a simple way, we will add water according to Markovnikov's rule or anti-Markovnikov's rule? According to anti-Markovnikov's rule. So I will add OH to this carbon and H to this carbon. So the product will be CH3 propanol. So we can see that the net result of hydroboration followed by oxidation is the anti-Markovnikov's addition of water. So in hydration, we have learned three methods. The first method, acid catalyzed hydration of alkene and oxymercuration demercuration. They added water according to Markovnikov's rule. And the third process, that is hydroboration oxidation, is anti-Markovnikov's addition of water. This much for today. Thank you very much. Have a nice day.